absolute maximum. So it's not, it's just as simple as that. So this is section 4.1. So when you hear local and absolute maximum, that is what all the things that talking about here is just about. So the next one we're going to look for a question in the test that looks as a question in the test that looks like that. So we are given this polynomial, and when we look at this polynomial, the behavior, the left-hand side is going to negative infinity. The right-hand side is going to positive infinity. So anytime the left-hand side and right-hand side are going in opposite directions, we know it's a polynomial with odd degrees. So this is an odd degree polynomial. So we can use the graph of a polynomial to decide the kind of polynomial it is. The next thing is that there is a local minimum. We cannot say that this is an absolute maximum, because really this arrow is going to negative infinity. So this is a local minimum. This is another local minimum. Now, this is a local maximum. Why? Because the arrow is going to infinity. This is another local maximum. Local. Okay, so that is not a big question. You should be able to find local minimum, absolute minimum, local maximum. It's just very simple. The next thing we want to do today is making sure we know how to do a quadratic regression analysis, because it's already in the test. So this is the practice test. So I want to make sure we remember how to do, we know how to do linear regression analysis, hopefully from your Algebra 1, hopefully. Now we want to make sure, then we solve polynomial equations. Polynomial equations are in 4.1, 4.2. It's going to continue to be in all the other sections. So now I'm looking for, okay, look at number 20. Number 20 gave us a table, the heart rate of an athlete while weight training is recorded for 4 minutes. The table below lists the heart rate after X minutes. Explain why the data are not linear. Why is it not linear? Simple. Let's check the. We all know that the distance between consecutive X is 1. So this is 1. This is 1. This is 1. This is 1. But that's not the problem. That's not how to determine. So we want to know what is the distance between consecutive y, which is the range. 140 minus 90 is going to be about 24. Yeah, 24. 122 minus 144 is 6.2. That is 8 approximately. 113 minus 144. So I'm focusing on the difference between consecutive lower limits. You see, so this is actually negative, and so on. This is going to be negative again. Therefore, the difference between consecutive the limits in y-axis are not equal, therefore it is not linear. The question is, find the quadratic model that, find the quadratic equation that models it. Okay, so we have explained why it is not linear. So we know it is not linear. And then we are told to find the equation, quadratic equation that will fit this model. In other words, I'm going to use my calculator. You better use your calculator. So we're going to do quadratic regression. So we go to our calculator. This question is already in the test. So you will see something like this. I just want to make sure you remember how to do it. So we go to STAT, enter, put in the domain in L1. So 0, enter, 0, enter, 1, enter, 2, 3, 4. So I have just entered the domain one by one. Now I'm going to the range, heart rate in beats per minute. So now I'm going to enter the heart rate. When it has not gone any minutes, 0, that was 90. So 90, enter. After 1 minute of lifting weight, the heart rate was 114, 114, enter. After 2 minutes, 122. After 3 minutes, 113. After 4 minutes, 91. So I have entered the X and the Y, and they must be on the same horizontal, they must be equal horizontally. And remember, in quadratic function, you cannot sort in ascending order. You are not allowed to sort in ascending order. Can you hear me, by the way? Hello, everybody. Somebody unmute yourself. Tell me whether you can hear me or not. Okay, you can hear me. That's good. All right. Okay, so now that I have put in the L1 and L2 in stat, now we want to, I would quickly get out of stat, second quit. Then I will go to stat again and arrow to calc. And what am I looking for? Quadratic regression. Quadratic regression is number 5. I'm recording this just in case if you forgot it. So I'm selecting number 5. And then I'm only asked to find the quadratic regression. So I don't have to turn on diagnostics because I am not told to find the coefficient of determination and coefficient of correlation. Okay, because I already know it is not linear. So it is quadratic. That's what they told me. And it's asking me, where is my domain? My domain is in L1. My range is in L2. Do you have frequency? No, there is no frequency. And this is asking me, do you want your equation stored in one of the functions? Yes, I want my equation stored in Y1. So I'm going to do vers Y-vers function Y1. Vers Y-vers function Y1. I just told my calculator that I would like the equation stored in Y1. And before I calculate, I want to go to mode, M-O-D-E, and I want to tell my my calculator that I want only 2 decimal places. 2 decimal places. So I'm going to select 2 decimal places. Because if I don't, it will give me 9 decimal places. I don't want that. Okay, now second quit. Then I'll go back to start and make sure I finish what I started. Quadratic regression, which is number 5. Okay, and then some things have already disappeared. So I'll go back and tell my calculator that I want the equation in Y1. So vers, Y-vers, function Y1, and then calculate. So I'm going to calculate, and it tells me that the quadratic equation is in standard form. And if it is in standard form, it has a negative leading coefficient, negative 7.79, and b is equal to, which is the coefficient of the linear term, the constant term is this. Okay, if I like, I can just look at the graph. And by the way, I want to make sure, let me go back and see the scatter plot. Let me actually go back and see the scatter plot. So that tells me a lot of stories. So second start plot. So I am going to go to second start plot. It's right here. And I want to turn plots on, and I want to do scatter plots. So everything is in order. So let me zoom 9. Before I zoom 9, I want to make sure there is no. So I'm going back to start plot, and then I selected plot 1, and I want to zoom 9 because it's already in order. Zoom 9. Okay, so I just saw that all the points, they look like it is quadratic. And this is my scatter plot. It is quadratic. All right. So what I'm going to do is go back and put a line on it again. I did before. Let me put a line on it again. When I put a line on it, it's going to give me a maximum. So I go back to start, arrow to calc, and quadratic regression is number 5. I don't have to do it many times. I just want to make sure that we get it. So again, remember how to tell your calculator that you want your equation in y1. So vers, y vers, function y1, and calculate. Okay, I'm going to calculate. And then if I actually go back to graph now, that equation I put in y1 will draw. So I see the quadratic function. And then why are the data not linear? We answered A. We answered that it's not linear because the differences between the heart rate does not have, it's not constant. Differences are not constant. So you write the equation here. And then if I want to see this equation here, I'll push trace. I push trace, arrow down, push trace, and arrow down. Okay, so that is the equation. And so you can write it as equation on your paper or from the main screen. So you write this equation here. And that is negative 7.79x squared plus 31.24x plus 90.23. So you see, it is better for me to have 2 decimal places. Makes my word easier. Okay, simplify your answer. Okay. Remember, they did not tell you to find the model without calculator. So if they tell you not to find the model, just find the model with calculator. All right. Okay. So now let's go to, today is about polynomials. So we're going to be solving polynomial equation. Try to solve polynomial equation. Sometimes we shall actually see, let's do this let's do this one. Everybody look, we have a right triangle. A kite is flying on a 65 feet of string. How high is it above the ground? If its height is 23. So the height is 23. Well, okay. And how high is it on the ground? So we're looking for the height. But I want you to know that this is a right angle. Okay, 23 feet more than the horizontal distance from the person flying it. So the person cannot be bending. The person has to stand at a right angle with the ground. So if you know that that's a right angle, the whole question is solved. Because you can use the Pythagorean theorem. The square on the hypotenuse side, let's say the hypotenuse side is x, is equal to the sum of the squares on the other side. Y squared plus m squared. Or I can say a squared plus b squared is equal to c squared. So the kite, the length of the kite is 65 squared is equal to this distance. Okay, so it says that is x minus 23. So x minus 23 squared plus x squared. So you are going to solve this quadratic equation. You got to solve this quadratic equation to, so we can simplify 65. I'm going to let you solve this, but you know you can solve it by simplifying. So if you do, this is difference of two squares. So we have x squared minus 2 times 23 times x plus x squared here. All right, and then x squared plus s squared, if we simplify that, we have, uh, what did I get? Okay, plus 23. Okay, let's first of all finish this one. Let me make sure that I put negative 23 here. Minus 23. Okay, squared. And then we have plus x squared here. Collect like terms and finish solving. If I collect like terms, I will have 2x squared here and so on, and simplify this. By the way, you can put it in your calculator and start solving. So the ones we are going to see today are going to be polynomials of high degrees. Polynomials of high degrees are going to be look lengthy. But once you know that this is a right angle, you know you can use Pythagorean theorem to solve that. Okay. All right, so we just looked at maximum and minimum. The next thing we want to talk about is behavior. What are the end behavior? What are the end behaviors of large degree polynomial? Or if I have this one is a fifth degree polynomial. So how do we expect it to behave? All right. They're all in the PowerPoint, but I don't want to go to that PowerPoint again because I have a lot to do. So what you want to note is that if it is odd, if the degree of a polynomial is odd, you want to remember that one side, behavior of the left-hand side will be going down, behavior of the right-hand side will be going up. And since it is a fifth degree polynomial, the number of turning points will be 5 minus 1. So we are going to have, hopefully, we are expecting that all the turning points will have cut x-axis. So we're going to have one turning point, second turning point, third turning point, and the fourth one. 1, 2, 3, 4. So the number of turning points is the degree minus 1. That's the number of turning points we're going to have in a fifth degree polynomial. Remember what the question is saying. The question is asking you about the end behavior. So the most important thing in this question is that the end behavior of an odd degree polynomial is opposite. One going up, one going down. And you have to also be careful with the leading coefficient. If the leading coefficient is positive, then it is true that this one will be going up and this is going down. So when the leading coefficient is positive, if A is greater than 0. So in this case, A is greater than 0. The leading coefficient is greater than 0. So the end behavior, it's not asking about the middle. It's not asking about the middle here, end behavior. So let's look here. Let's look up here. The end behavior of this graph is B, because we know it is an odd degree polynomial. The leading coefficient is positive. Therefore, the right is going up, the left is going down. Okay, but if the leading coefficient is negative, for example, if I have a third degree polynomial, suppose I have x to the power 3 minus plus 2x squared plus x minus 1 is equal to 0. Well, this is a third degree polynomial with a negative leading coefficient. Guess what? Then the left is up, the right is down. Why? Because there is a negative leading coefficient. Because of the negative leading coefficient, the left goes up, the right goes down. Okay, well, let's look for another one. This is an easy question. That is why we are making sure that, so that's an easy question. Describe number 26. So whenever all the places, suppose you see 3 questions like this, they are easy questions. And if you see another question that says maximum, minimum, and it's asking you, it's an easy question. Even though there are many degree polynomials, they're easy to answer. Okay, so the first thing we want to ask ourselves is the leading coefficient negative? Yes. What is the degree? Degree is 3. The leading coefficient is negative. So we are expecting an opposite behavior. The left is going up, the right is going down. Any question? This is really easy. Kind of easy questions you don't want to miss. Okay, now let's get all these easy questions. So we come back to solve application questions. We have done complex numbers, so we're not going to be doing it again. We have also done this kind. I hope you can solve this problem. We have solved the problems like that. I sent you an email to remind you that next there will be no other class before the test number 2. Okay, I will open that test on Sunday evening because you have a quiz also. So test number 2 and quiz number 2 will be done between Sunday evening and Monday night. Okay. Okay, so very soon we come back to these application questions. All right. Find the minimum y value of this. I hope you remember how to find the minimum value. You go to, I hope you remember. Hello, do you have any question? Do you need any question? Do you need us to do number 33? You should also be able to do number 34. Remember, we did it, and you need to know how to do this. What you want to do is, if you're told to find the minimum, now you're not told to use any, do it algebraically, go put it in your calculator then. So if you go to your calculator, put it in, and ask your calculator to give you the minimum point. I did it the other class, and you can actually also see it now. Solve the following equation. For an equation with a real solution, support your answer graphically. Okay. I think you can do number 35. Okay. Match the rational function. We haven't done this one, so I want to make sure we do it. We haven't done this one. Match the rational function with the appropriate description. Choose the correct attribute. Okay, the question will be here, find the vertical asymptote. So you will say that this has a vertical asymptote. Anytime you're told to find the vertical asymptote, you must say, in fact, you may not be told to find a vertical asymptote. You can also be told to find the domain of the number in number 37. So I will actually go to that homework 3.5.2 because that's where they are. Find the vertical asymptote. What you're going to do is collect the denominator, x plus 2, equate it to 0, and solve for x. So x is equal to -2. Therefore, the vertical asymptote is at x equal to -2. Okay, so the vertical asymptote, okay, choose the correct attribute of the rational function. The vertical asymptote is x equal to 3. No. The y-intercept is at, not going there. The vertical asymptote, okay, this is the correct one. All right, so we're not going to waste time on that. It's not that bad. Describe the absolute extremum. So there is only one absolute extremum here. Absolute because there is no other maximum point. So Mn, the point M, comma N is a maximum an absolute extrema. The point AB is a local maximum. The point CD is a local minimum. It is local because I know that these ones are going down indefinitely. So that's not it. So notice that all these questions on absolute minimum, absolute, they're easy questions. You want to actually do it very well. Okay, true or false? Every real number is a complex number. Yes, because every real number, suppose I have question number 3, I can write it as 3 plus 0i. So every real number is a complex number. We already did number. I think we did. Hope we know that you have to rationalize the denominator here. We did it already. Rationalize the denominator there. Okay, and here you're told to find the minimum value. I'm expecting you should know how to find the minimum value, but we can still do that. We did it the other class. Okay, how high is the baseball after 1 second? All right, so this question is saying how high is the baseball? It's another way of finding the function. All you have to do is f of 1 or s of 1. After 1 second, just substitute 1 here. After 1 second. The maximum height of the baseball. I just want to let you know, anytime you're asked about the maximum height of a baseball, oh, by all means, put it in your calculator. Okay, let's find the maximum height of the baseball in number 42. So let's do that. Maximum height of the baseball in number 42. So all you want to do is put this data in your calculator. Y equals, and before I start graphing, I have to de-highlight plot 1. Make sure that nothing is going to screw you up there. Okay, then put the equation in number 42 in your calculator. So negative 2t squared, and I'm going to use x for t. Negative 2t squared right here. Okay, and plus 38 plus 38x plus 8. All right. And then you want to grab this equation. But before you grab the equation, go to your windows and make an estimate of the windows. So I am actually going to start from negative. Let me make it from negative 15 to 15. And also I will make the other one negative 15 to 15. If it doesn't work, then I will zoom fit. So, and then I'm going to try to sketch